Okay, so this is the Endo meeting on Wednesday, May 14th, 2025. We have two topics on the calendar, or on the agenda for today. First up is Alex, who's going to give us a taste of a tool that he's built for exploring reference graphs within JavaScript. And then I have a conversation with Chris scheduled to dig into some design issues for the module loader and how to avoid round tripping through Babel's syntax tree, round tripping syntax through strings. Alex, please go.
Hello, everyone. My name is Alex Vincent. I've had a project in my toolkit that I've been building called ES Membrane, which is a way of separating object graphs in a, well, it's an intricate project. As part of it, I was trying to determine when one of my components was holding a reference to something when I didn't intend it to. I wrote some garbage collection tests. I knew ahead of time that it was non-deterministic, but it usually gave me the right idea. I'm sorry, the right answer, except when it didn't. Um, on the if it did say I was holding an object, it wouldn't tell me how I was holding that object. And at one point, my garbage collection tests were consistently telling me I was leaking memory in one of my classes, but I couldn't find the leak, so I needed a tool to show me. And I'd started crafting this project called ES Search References. And early on, I realized that the question, is this object unreachable, is really the wrong question. That's the question garbage collection is supposed to be solving. What I was really trying to ask is this object unreachable from a given finite set of known objects? And then it's a question of enumeration. Vanilla objects, arrays, maps, no problem. You can deal with that fine. But if you have a weak map or a weak set or private class properties or other internal slots, closures, etc., well, they're not exposed to the outside world for good reason. They also hemmed me in. So it gave me really what I saw as three options in order to figure out how am I getting from object A to object B. I could implement large parts of a JavaScript engine to simulate what was going on. No, thank you. I could intercept the built-in APIs and traps, say a tracking weak map, but that would mean altering the code that I'm trying to run. And again, no, thank you. And it wouldn't cover closures anyway. Or I could use an existing JavaScript engine that I could hook into and have it run the scripts for me. Um, there's also a question of how do I actually store and show those results in some way that's useful. Uh, and so I went back to the basics of graph theory, nodes representing objects and edges representing named relationships like 0, 1, color, internal slots, etc. As part of this, it quickly became apparent that maps have a subtle relationship to their values. You can have a key pointing to a value, and that's great, but it's actually more than that. If the map itself is unreachable, but the key is reachable, then the value is not reachable. It's joint ownership in that scenario. So I had to create new nodes for these pseudo objects. And this is my solution here. It's a project called ES Search References. It uses Engine 262 as a guest JavaScript engine, meaning that I am running JavaScript in the browser here or in Node.js, and it's running Engine 262 as a guest engine where I can implement a custom search references function. The search references function takes four arguments: a results key, so you can have some idea why you're searching for a value, the target value, an array of held values, and whether you want strong references only or if you want to see weak references as well. And with this, you can write a purpose-built script to show you the results of one of your searches here. If I can get this thing to scroll down a little bit. Here we go. For instance, I've got a simple script here where I can say, hey, I'm looking for a particular symbol, or I'm looking for a particular value. And I can draw a graph in a nutshell showing you how you get from a target to a particular value. You have the held values array that you start with, the property name, and the target that you're looking for. And this can get a little bit complex, but it's actually useful this way because you can show whether it's a member of a held array or if it's part of a proxy handler or if it's part of a promise chain, et cetera, et cetera. And the whole point is to see how you get from one point to another. And as I can show you, I was able to run multiple scripts in one go here. It can even get really complex to the point where I can show you a much bigger graph where this is a implementation of a what I call a one-to-one strong map. It's really a weak map of strong maps inside them. And the idea is I can tie one object in one graph to another object in another graph, or proxy more accurately. This is how ES membrane actually does its multi-graph support, its hypergraph membrane support. I'm going to skip over the how it works section for in the interests of time. But basically, what I can see is I can see the relationships saying, okay, I've got this property 0 of object 2, and I've got these pseudo fields. Well, and it leads to a long chain, but you can actually see the visualization at a glance how you get to the target object that you're trying to get to. And if you can't get there, great, it'll show you null, you can't get there. So let's see here. We've got some other tools here. I have a search log that shows how the graph was built. I have the search results. The nodes represent objects. The edges represent the names of the properties of how you get there. I'm using a number of different tools. Engine 262 I mentioned for the guest engine. GraphLib, which is a library for storing a graph as JSON, with another tool, Dagre, D-A-G-R-E for layout, and Dagre D3 for the rendering. And basically, I'm running this search references, these scripts in Engine 262, and it's creating a graph of the JavaScript implement, the Engine 262 objects. It translates that graph into native JavaScript objects, and then an object graph library. Um, excuse me, I'm getting my tongue twisted here. It takes that object graph implementation. It takes those nodes and edges. I'm sorry, it creates the GraphLib node and edges. Then it does some polish. If we're looking for strong references only, it'll strip the graph of any of those strong references. And then it'll create a summary graph where objects that were completely unrelated, say the first element of the array is first value, that's unrelated to any search I'm doing, so it's not going to show that in the graph. And then it's up to the rendering tools to generate SVG markup here. So one of the things, the math model is not necessarily entirely correct at this point. This is a prototype, it's a work in progress. But for instance, if you have a weak map, this is how I'm currently representing it, where the key is a branch of a pseudo node and the value is another branch. In the earlier conversation, we came to a consensus that what it should be is the map and the target point jointly to a pseudo node that points to the value. I just haven't implemented it that way, at least not in this visualization. And about a month and a half ago, I was showing this or illustrating the idea before I'd implemented all this to my boss's boss. And she asked, well, can this tool be used to find leaks in our platform? To which I had to politely laugh a little. Even a simple class like one-to-one strong map, the graph can get surprisingly large. And the document object model is a couple of orders of magnitude more complex than anything we have in pure JavaScript. Plus, you have to have an implementation that can run in Engine 262. Maybe a library like JS can do it, but I have no idea if it would actually work. And Engine 262 itself is not very fast. Um, as I said, this is a prototype. It's a proof of concept. It has minimal UI, and so it has a long way to go. Plus, I'm not that familiar with visualization tools like D3 or Cytoscape that can actually present this graph to you. And will it show me the connections? Well, sometimes. For instance, in the one-to-one map that I had drawn here a moment ago, it will show me connections, but sometimes those connections are currently orphaned. If you look in the upper right, in the upper center of this graph, we have this pseudo node that has no apparent parent. Well, that actual parent is going to be down here, and it's just a bug in the algorithm to generate the graph. Ultimately, I am going to be asking for if people find this useful. I think that they will. And I'm going to be looking for people who want to join in on this project, help me build it out, and maybe take it over, improve it from where it is now. That's pretty much everything I had to say, Chris.
That's it. That's that's it in a nutshell. And if you want to learn more, I can give the group 5 minutes to answer questions, and there is a longer presentation I will link when I post this recording to the tubes of you.
Questions, feedback, first impressions?
For the record, there's some visual applause.
Okay, I can't see that right now.
So we've been building a much simpler version of exploring what is reachable, but for a totally different purpose. So for us, reachability was what's reachable from a reference in terms of checking whether we are not exposing some references that over a bunch of uh, property lookups could lead to exposing global this, for example.
Right.
And while it had a similar vibe, it was by far not as complex, but I would be interested to look at whether we are exploring the reachability in our sense in total, or if we're missing something. So that's the overlap I'm seeing, and I'm gonna let uh, my my teammate Gal know that this happened. I mean, I already did as you were starting, and he might look into it further.
Okay. To answer that question, I will note that Mark was asking about creating a similar visualization for ES membrane, and which is a security abstraction mechanism, which you may be familiar with a little bit. And in the new hypergraph membrane model that I created, if you look straight down the z-axis where we separate the object graphs, there is a similar visualization that you could do theoretically, where the nodes and the edges can be drawn that way. And it's on my to-do list. I literally have not had time to get to it yet. I was working on this at 1 a.m. 10 hours ago, trying to get ready for these presentations today. So it's on my to-do list. I'm thinking about doing it anyway. I just haven't gotten there yet.
Okay. And somewhat unrelated question about ES membrane. Is it practically usable if we would want to put a lot of membranes in the program? Would it have as big of a performance impact as our earlier attempts? Because I work with someone who has written a JavaScript membrane implementation, at least a proof of concept, and it was so slow that it was abandoned.
To answer that question, ES Membrane is undergoing a complete rewrite from what I wrote 6, 7, 8, 9 years ago. So, well, no, on whether it's whether it's usable right now. Um, I am completely redesigning it from the ground up. In my approach, I'm going to be providing decorators that you can apply to various object fields, methods, etc., to indicate whether a value should be hidden or should be exposed or read only, that kind of thing. But
Mhm.
I'm not there yet. Okay. The rewrite is underway. I built this project to support that. Um, but it's taking me a long time. It's a spare time project. As for whether it will be fast, don't know. I just don't know yet. Um, at this point, I'm trying to get it working and trying to make
Okay.
sure that it's correct.
Yeah.
Optimization.
If you get to a point of something resembling a walking skeleton, I could offer some of my time to put into benchmarking it.
I'd actually appreciate that.
Okay, let's stay in touch in that case, and I'm looking forward to it.
Okay.
All right.
Anything else?
All right. Uh, that's time. Thank you for the presentation, Alex. This is a great group for this tool. Chris, how's it?
Yeah. Whoa. Okay. You're over here. Hi. Um, so the thing that I wanted to talk about was um, in Lava node, um, we are using SES, of course, and we're using the evasive transform package. And both of these invoke Babel parser and parse out an AST for different reasons. I believe the SES one happens first, or no, maybe the evasive transform one happens first, and then the SES one happens. But yeah, we've kind of brought up the way that old Lava Melt used to work is that we didn't do that AST parsing because of performance reasons. Obviously, there are some considerable trade-offs in doing it that way with regular expressions or whatnot. But so like I think we could probably stomach one parse of every given module with Babel, but two is pushing it, and so it's just extra work that's happening that I want to figure out how to avoid. Like, can we somehow pass this AST around? I mean, there's different ways to attack it, and I'm wondering like what's feasible. Um, you know, if anybody had any ideas about how we should go about that, because it's going to be very slow. So
Yeah. I think that this is an attackable problem. The yeah, the currently if yeah, so I see no reason why we couldn't apply the evasive transform by default always on for every module source that we parse. Like we could just integrate the Babel evasive transform, the Babel transform itself as so but we also need to be able to do the evasive transform based off of a string, and that API is different. Um,
Mhm.
and like a breaking change to the Babel transform does not correspond necessarily to a breaking change in the evasive transform. So there's a factoring question, I think, is like every Babel upgrade has to be coordinate a change, right? If we change out the Babel version, we have to do if the Babel version underlying the evasive transform today bumps a major version, that's not a major version change for evasive transform because none of the types from Babel are exposed. So
Mhm.
there's so like in terms of just managing change, I think we can do this by ejecting evasive transform Babel, the core of evasive transform, into a package that is free to move and be a shared dependency of module source and evasive transform, and then just always run the Babel transform for evasive transform as part of the pipeline for module source construction. I don't see any reason we wouldn't want to do that. But the end goal, the end effect would be that you would do one Babel parse and code gen with the transform stacked inside of the sandwich.
I can offer some devil's advocate. If the entire code base that is being run has no need for evasive transforming, in that case, it has no way of avoiding the penalty of running the transform.
We can avoid the penalty of running the transform by making it an option. And in fact, we probably should make it an opt-in. I don't, it seems right.
Yeah,
Um,
opt-in sounds good.
we can't in that scenario really avoid entraining the transform's source code, and that can be a liability for bundle sizing, but I don't think that's really a concern since this is all server-side tooling in general. It's possible to use this on the client, but
Yeah, I did once, but it was for very silly things.
yeah, I think that the kinds of tools that you would do on the client side can stomach having the additional bundle size of entraining Babel. I mean, you have to entrain Babel. It's huge. The
Yeah.
transform is that much more.
One almost opposite alternative that I was thinking of would be to switch from wherever we have strings to representing them by some sort of the source object that by default contains a string, but then lazily parses it whenever first necessary, and then retains the reference to the result of parsing, which means we could throw around the same logic where toString and value of that object would produce a string if necessary, or we would more directly use the API. But that would let us transparently parse only once. Is that uh, is that gonna be possible?
I get it. The basically the value of that would be that you could construct scenarios where you have like an acorn transform and a Babel transform, and then I think that having that opaque source token that is just like a carrier for an underlying syntax tree representation that might have to be collapsed between transforms is
We
valid.
would have to standardize on one ASD implementation, definitely. There not interchangeable, and
I mean, you
not
can
even
either,
reliably translated.
yeah, you can either standardize the syntax tree or just force a round trip when you change. Um, and I would consider that necessary if we were talking about making, if in the future we have a conversation about at TC39, if we were to have a conversation at TC39 about um, having transformation hooks, um, so the compartment proposal contains a transforms array on compartment, and those transforms are forced by eval. And and each of those transforms is trampolining on a string type. Doing anything more complicated than a string type for that array of transforms is entrains a conversation in TC39 about standardizing.
Standardizing Babel. I
Yes.
would love that.
Yeah, and no, I'm not going to have that conversation. In fact, I think that in order to avoid that conversation, it would have been valuable to say that you can have an eval transform hook that can only do one transform. And if you want more than one transform, you can multiplex that transform in user space. Just uh, having an array of transforms invites a conversation that I don't want to have. But that's where it is. And we do have to have a transform hook for eval, I think, in the compartment proposal, because there's no other place to put the eval. There's no other place to drive. Um, we need that hook in order to drive user space eval if it needs to have the evasive transform applied or whatever. Um, which is to say, that's why we still need that the string-based evasive transform API. There needs to be an integration point for compartments.
I just realized that I don't understand something, uh, or maybe it's just how I misheard it. But whenever we switch from the shim implementation to having evaluators in the standard, we do not need evasive transforms because we do not need the censorship, because we don't get tricked by certain weirdnesses.
Yeah.
So
Yeah. The
why
fact
do
that we
we
have,
want that?
yeah, it may be a historical artifact at this point because uh, we were, yeah, it may be a historical artifact. It might be something that we don't propose. We might not propose the eval transform hook uh, when it comes down to it. Mark, hi, Mark. Is Mark present?
I see two of them.
I am present, but I was only listening with half an ear, so
Yeah. So currently the compartment proposal has, as proposed, compartments have a transforms option on the constructor. The
right.
transforms are applied for every string that will be evaluated by compartment.evaluate, and maybe also dynamic eval if dynamic eval is a possibility in the native implementation. Is that the intention to run these transforms for dynamic eval?
That's a good question. I will need to.
The real
Yes,
question,
yes, yes.
the real
The answer
question,
is yes.
okay. And the real question is why? Do we need that, and would we need it for a native implementation?
Okay. So we would need it for, let's see. Oh, I see. Right. Okay. I'm going to argue both sides. It's in the shim implementation where modules require the Babel transform. It's cheap to add this transformation requirement because you're already transforming. In a native implementation, you're not already transforming. There is no Babel. So adding this option would be very, very expensive to support if it were done in user space. That kind of, in fact, defeats a lot of the purpose of preferring a native implementation. And we couldn't move the option into the native implementation without standardizing Babel. Some of these words sound like things I'd overheard in my half listening. So you probably already covered that. So that's the negative case, which seems pretty damn strong to me.
The case, I think if I were to frame that differently, all of there are two cases. There's the native case and the non-native case. There's the shim case and the native case. In the shim case, you need to do the module source transform and the evasive transform. In the native case, you need neither.
Right. But since you always need those in the non-native case, there's no reason to provide them as a compartment option. You could just build them into the behavior of compartment.
Right. So that covers the module case. The module case doesn't use the eval transforms at all. We do the transforms out of band in the import hook.
Okay. So let me talk about the other motivation for the transforms that are continue to be
right.
something.
The metering implementation was one of the original.
Yeah, metering implementation is a great example. So the idea was that one of the forms of attenuation might be that you're restricting the subcompartment, the new compartment, to implementing a language whose surface syntax is, even as I'm starting to say this, I'm already repulsed by it. But you could constrain the surface syntax of code accepted by the new compartment to a subset of JavaScript. You could map some elements of JavaScript to something else without losing the semantics. You could shim forward syntactic features that were not yet implemented by the platform. And all of this once we're thinking of this as something that would need to be implemented natively, it seems like crazy talk.
The general case. So there's metering and instrumentation. Metering and instrumentation both benefit from the same key mechanism. That is to say that you can endow a compartment with a global lexical that cannot be discovered on the global disk. And then you must then also forbid that identifier from being uttered in the source in any source that gets evaluated within the compartment. And for that, you need a transform hook. You don't need a transform hook. You need an analysis hook that can throw an exception.
Okay, and the problem is that for a native implementation where there is no native parser, there is no good way of achieving that.
Right. So if you had a native reflect parse, as Kumavis points out in chat, then you would have somewhere to stand.
Yes.
Somewhere to stand to have an understanding that the parser you're using corresponds to the native parser that's actually implemented.
Yeah.
So
then if we had a native standardized parser available, there's all sorts of things that we could do that we would like to do.
And that's been the case almost as long as I have been aware of the existence of the TC39 shadow cabal of standards of language standardization. That's when around that time is when Dave Herman proposed reflect.parse, and the history of that is that reflect.parse never made it forward at TC39, but was the basis of Arieh Hidayat's S Prima, which I believe was the basis of Babel for having a syntax tree in user space. And they still closely resemble each other.
Mhm.
But we don't have a standard parse tree.
Yeah, I would love to have a standardized parser in the platform.
Well, in any case,
But
I think that this answers my question that if we were to go to TC39 and present a compartment proposal that includes a transform, for one,
yeah,
I would have a single transform, not a transforms array personally. We currently have a transforms array in the compartment proposal.
mhm.
But
There's actually a reason for that,
we
which
I don't
is
think that we would even suggest it at this stage until we had a reflect.parse in the language.
That's right. That's right. So I think the thing to do is get rid of it from the proposal. Don't ask XS to implement it. Presumably they have not implemented it.
To the best of my knowledge. Yeah.
Okay. I mean, can't imagine how they would since they don't have a reflect.parse. Um, I mean, at least since in the native implementation, they have access to the parse tree, but that doesn't give them a standardized way to express a transform. So, yeah, I think we just remove it from the compartment shim in order for the compartment shim to continue to be a best efforts approximation to what we want to propose. The necessary transform because of the infidelities, non-fidelities of the compartment shim to the proposal. We still have to do, some transforms, but we just bundle that into the shim behavior. So yeah, let's get rid of it completely, and then if in some future millennia there comes to be a reflect.parse, then we can we might want to do something on top of compartments, but by then it'll be too late to do it in compartments.
All right. Chris, that was I'm fine with having gone on that digression because I think that you have the information you need on implementation direction.
Yeah, I have an idea of what's supposed to happen.
All right. And now I have an idea of what we ought to do on the standard side and also why. Yeah. Yeah, we don't need that. We might not even need the not going to touch that yet. We can't make breaking changes. But yeah, so an evasive transform Babel package that has the core of evasive transform that can be a shared dependency. And then in module source, have an option to apply the evasive transform. And then we'll just use that in our bundler.
Well,
That being said, not all evasive transforms need to be based on AST. Are we going to retain some of the string-based ones? And if that's the case, is it going to be problematic if we want to run them on the string before it gets parsed?
That a Chris question?
can you repeat that, please?
I'm really bad at repeating the same thing I just said, but I'll do my best.
It's not in your token buffer?
No. So we have some evasive transforms that are fine being transforms that apply to a string, and they're probably more effective that way, performance-wise. So if we wanted to,
what are some examples of evasive transforms that don't operate on the AST?
avoiding sequences that resemble HTML comments. They
So
are.
you can't accurately avoid that without parsing.
No, you can't
You-
completely avoid that when you're
When
working
you
on
do
an
parse.
AST,
Yeah, that's
because
true too.
yeah,
Yeah.
yeah, because minus minus greater than sequence is or is not an HTML closing comments depending on white space.
Right.
Not
What
to
happens
mention, we have to
right there?
censor comments.
Right, but hold on. HTML-like comments are only recognized in scripts, not modules. And since we're emulating modules by transforming them into evaluable scripts in the shim, okay, HTML-like comments, you're probably right. The issue is what happens, I see, in the module source, if an HTML-like comment appears and it can validly be interpreted as JavaScript, in order to accurately treat it as module source, we need to insert the white space so that it continues to be recognized as JavaScript operators, and implement the semantics that it would have had in the module. Do we do anything like that?
Currently, as far as I remember, we're focusing on putting the space where it belongs, and we are risking breaking HTML comments if concatenating them into a larger string is a functionality of the code. But we are only doing this to avoid SES screaming at us
Right.
with the censorship. And if we could narrow down the censorship to only look at the first line, which I believe would be sufficient, but don't feel confident enough in my knowledge of how HTML comments are being interpreted. But that sounds like it could be fine. On the other hand,
I'm fine narrowing the censorship down as long as it's still conservatively safe. And that would require very, very careful reading of the spec on HTML-like comments. If I recall, there was one particular opportunity, which is one of the two, I don't remember if it was the opening or closing, was only recognized as an HTML-like comment if there were no tokens to its left on the line. I don't recall anything having to do with anything about the first line.
yeah, I thought the opening comment would only be recognized if it's the first thing on the first line of the script. But then recently coming up with a test case for something unrelated, I wanted to use the evasive transform to actually change the meaning of the fragment of code that I'm pushing through our software. And at least whatever parsing Webpack does to verify whether the sources being bundled are correct JavaScript is totally fine with a sequence of one, the number, opening comment, whatever, closing comment, and another one as a number. So potentially more. So that challenges the assumption that the HTML comment has to start at the beginning of the line. But as far as I remember from the spec, it was only supposed to be a thing on the first line because it was the mechanism to hide JavaScript from things that don't recognize the script tag.
Yeah, so what you're saying points out an interesting constraint, which is we're not just concerned with what the language engines do. We're also concerned about any tool that we expect people that we want to not that we want to not create unpleasant surprises that might be operating on our code. God, this whole area is such a mess. So
Yeah.
the
One thing
so
can,
let me just finish the point. So the thing about including possible tools is that the actual 262 spec on HTML-like comments is no longer necessarily accurate with regard to our concerns. It makes sense to be overly conservative because once you open it up to tools, I guarantee that there will be some tools that have misinterpreted the spec and implemented something a little bit different.
So I can speak a little bit to the spec itself and remind everyone that there are two different flavors of HTML comments.
Oh, no.
The HTML open comment, the one that starts with less than bang dash dash, can appear anywhere. The HTML close comment, the one that is dash dash greater than,
Yes.
must not be preceded on a line by other things.
Okay. That's consistent with what I remembered. I just didn't remember which one it was. So the close comment is only recognized if there's no preceding tokens on the same line. And for neither one, is there anything about first line of the code? It's just
there is a special case to make sure that the HTML close comment, the one that it is preceded by a line terminator or comes at the start of the file with, you know, comments and white space not counting.
wait, if it can proceed by, say that again?
All right, so the one with the line-based restriction is the close comment, the dash dash greater than.
Okay.
It can always be preceded on the same line by white space and single line comments. And it is also allowed to appear at the start of the file with no preceding line terminator at all.
Well, if it's at the start of the file, then it has no, I don't understand why that's not covered by saying it just has to not be preceded. Oh, I see. It's not just tokens. It's not that you're saying it's also the single line comments?
Yeah, so if you have, you know, the slash star comment with no line terminator, that is still allowed before the HTML close comment.
And that is in fact necessary for the original function of the thing.
Yeah.
Mm-hmm.
Like the brief period in which this pattern enjoyed material use was the window between Mosaic and Netscape. It's like Netscape was born with JavaScript, and Mosaic had to have this migration path.
Yeah.
Okay, but ZB, did you have a question for me?
I mean, I wanted to figure out whether it's going to be problematic if some of our transforms are better off transforming the string sources. And that would mean they would have to happen before or after, and in this case, preferably after the Babel transforms, because the output of the Babel transform Specifically, the white space resulting from that is going to be significant for this transform.
I mean, we can use the module transforms facility of I don't know, whatever compartment mapper or wherever that goes in the compartment mapper.
Yeah. Module transforms.
But not for this one, because module transforms will happen before the evasive transform that we want to put in a compartment somewhere.
Wait, what's the order that needs to happen? We need to
So
do.
what we want is we want the AST-based transforms to finish and then give us the resulting string on which we would need to perform this evasive transform for white space before we reach censorship, which is also string-based. Or maybe we could change censorship to be much, much more specific so that we don't need this flavor of a transform.
Or you can bring your own module source constructor to the compartment map. I believe it's a hook. If it's not, we can make it a hook. That doesn't work. No, that doesn't compose.
What's happening now is we're doing our bespoke replacements, and then we do the evasion from the evade transform or evade censorship module. So
wait. There's two separate things. Evasion is what prepares the code to not cause an error from censorship. Censorship is built into SES, and whenever source is supposed to be evaluated, it gets checked whether it contains specific patterns in the text, regardless of where they are, including comments.
Yeah, and you said that exactly right. It's a property of SES. It's not a property of hardened JavaScript.
Yes.
And anything that is intended to be forwardable to a native hardened JavaScript shouldn't apply that transform.
Right.
Well,
okay.
a native hardened JavaScript will not do the censorship, and code that needs to be portable should not run an evasive transform.
So how do they detect whether their target is, native or SES?
Oh, who's they?
I suppose the code doing the evasion would not, since you're not even doing the module transform, so it's not an issue because the evasion happens as part of the transform, and the whole transform is gone with the native target.
The current migration story is that there are currently two bundle types. Well, there will be two bundle types, our existing bundle type, which is precompiled, and our future bundle type, which is not precompiled. And with bundles that are not precompiled, it becomes the platform's decision at time of import whether to apply the transforms or not.
Okay.
Yeah. So I think that the answer to this question is that if we need to have string-based, like regex-based transforms applied after the module transform and after the evasive transform, that has to be an option or a default behavior of the module source constructor, which would and by dint of using the module source constructor, you would get the decision about whether to apply the transform, because the native module source constructor would not do this. The shim module source constructor would.
So I thought I didn't understand choice. I mean, what you said, the last thing you said is exactly right, which is the native one would not do it, and the shim would do it. So there's no choice to express.
There's no option. It's the election is made by which module source happens to be available in your target environment.
Okay, good.
Okay, ZB. So what we're doing is we're doing these regex transforms in the module transform. We're doing the evasive transforms from the module also in the module transforms. It's the last one that happens. And so it looks like what's going to happen is we're going to take that call to evade sensor sync out of our module transforms, and that's going to happen automatically or whatever if you hit an option, and then we'll be fine.
Yes.
Right?
Yeah.
Yeah, that has to happen in the implementation of module source.
Oh, Chris,
Yes.
another exception we need to note somewhere to our column preservation through the module transform is that we obviously can't do column preservation for valid operators that look like an HTML-like comment.
Mm-hmm.
Okay. That's not necessarily true because there is no overlap between valid JavaScript that resembles closing HTML comment and what the spec is willing to treat as a closing HTML comment. And since we are rejecting any code that has an opening HTML comment correctly, I think we would even potentially be fine ignoring closing HTML comments.
I did not understand that. On the input to the module transformation, you've got module code. Module code does not recognize HTML-like comments. It would treat either HTML-like comment like the sequence of valid JavaScript operators it looks like, and therefore, given that that the shim is doing a module transform, I think it does make sense for it to insert the white space that separates the operators so as to preserve the semantics of the code as module code.
But the spec, and in this case, parsing, is definitely being correctly implemented because we're talking about parsing by the engine, not by tooling.
No. I'm talking about parsing by tooling because I'm talking about the module transform. That's parsing by tooling.
Okay. Yes, but what I'm trying to argue here is that I think we don't need censorship for closing HTML comment because it's not possible to have it be valid JavaScript before and then get misinterpreted into something with different meaning if there was no preceding opening HTML comment.
No. The HTML spec on HTML-like comments has no matching of opening and closing. They're unrelated to each other.
But they would not change the meaning of the code at runtime. They
X minus greater than Y is a valid JavaScript expression interpreted as operators, and that is the meaning if it appears in module code, since module code does not recognize HTML-like comments.
Yeah, and then in script, it would also not be interpreted as a closing HTML comment because it's not starting at the beginning of a line, nor is it prefixed by only white space and slashes.
X new line minus minus greater than y.
Okay, my bad. Sorry for wasting the time.
There it
Okay.
is. There it is. Okay. We have, what is it? Reductioed this absurdum.
Yeah. It did not need to be reduced to be absurd.
All right. Well, we're over time. Good conversation. I think that we have clarity on next steps. So yay, everyone.
Yep.
Good.
Chris, do you have the ball?
All?
The ball. Is this your action item or do you need assistance?
Yeah, I think it's me.
Okay, awesome. I'm on the hook for your reviews, of course. All right, thanks, folks. Let's call that a meeting.
Thank you.